Hello everyone, I hope you are doing well. My name is Agustin Boeri. I'm a PhD student at the West Florida Research and Education Center. And today I'm going to talk about the status of the Bahiagrass Improvement Program. For this presentation, I'm going to start giving a little introduction on water resources, and then I'm going to make a summary of the past research. I'm going to finish giving an update of the current field trials on Bahiagrass in golf courses and salt farms. So, why this topic is important? Irrigation water use includes the water applied in golf courses, parks, home lawns, and agriculture. Irrigation had a substantial contribution in water use. In 2015, the water withdrawals from irrigation represented 37% of the total withdrawals in the US. This graph is showing the water demand for development areas in agriculture in Florida. On the y-axis, you can see the water demand in gallons per day. And on the x-axis, you can see the 2010 baseline, the 2070 trend, and the 2070 alternative. The projections indicate that if we continue with the current water use trends, developing water demand will increase 100% by 2070. The alternative scenario predicts the future water demands if we modify our current practice. Therefore, water use must be reduced in Florida's landscapes to remain sustainable. Bahiagrass, a warm season grass native from South America, is adapted to sandy soils, low fertility, and drought conditions. The use of Bahiagrass will reduce irrigation and fertilizer inputs. However, cultivars available in the market have negative aesthetic attributes, such as a lot of seed heads, poor color, and lack of density. The US breeding program has identified several promising new lines with superior turf qualities. On the left, you can see a graph showing the color, turf density, and quality of Argentine Bahiagrass and 5 experimental lines. On the y-axis, you can see the rate scale from 1 to 9, 1 as a poor and 9 as excellent color, density, and quality. On the x-axis, you can see all the genotypes. The first two lines, M27 and M98, are Argentine mutants. The rest, WEMS12, WEMS18, and WXR02 are Wilmington mutants. In general, the Wilmington mutants have better color and turf quality compared to the Argentine types. And WEMS12, this one, highlights from this group showing the darker green color, a lower canopy, and only produce a couple of seed heads. On the right, you can see a picture showing the morphological differences between Argentine and WEMS12. In 2017, we tested 12 commercially available herbicides on the new lines. In general, the Argentine mutants show a graded herbicide injury compared to the Wilmington mutants. However, the herbicide growth reduction effect was greater on the Wilmington mutants. Looking at the herbicide options, Bahiagrass, Bactriol, Speedzone, and Quicksilver were safe to use. Spotlight, Sethammer, and Confront can reduce growth by 50%. On the left, you can see a graph showing the percent injury of 4 of the most damaging herbicides applied at 2 rates. The y-axis is showing the percent injury, and the x-axis is showing the days after treatment. The red line is showing the acceptable injury threshold of 20%. Certainty was safe at the level rate, you see here, but it can cause turfgrass injury above the acceptable threshold where the label rate is exceeded. In general, the rest, as a claim, dismissed South and Celsius, reduced the growth and caused damage above the acceptable threshold, even applying the herbicides at the label rates. We evaluated the root characteristics of this line by growing the grasses in clear acrylic tubes under drought conditions. This graph is showing the distribution of root length density on 3 different soil depths represented in 3 different colors. The distribution of root length density is represented on the y-axis, and the genotypes are represented on the x-axis. Grasses with more even distribution of roots were more drought responsive. So under drought conditions, WEMS 18 and M98 had the more even distribution of roots, while WMS 12, WRX02, and M27 had a similar root distribution than Argentine. This graph is showing the turf quality of the grasses at the end of the experiment. The blue bars show the well-watered treatment, and the red bars show the dry down treatment. No difference were observed between the lines when the grasses were irrigated. The grasses did show turf quality differences at the end of the dry down. Most of the new lines are drought responsive genotypes with an enhanced aesthetic component. And WEMS 18 was the top performing genotype of this group, suggesting that it has potentially has an improved drought response. In 2018, we also evaluated photosynthesis, chlorophyll fluorescence, and transpiration responses of these grasses under drought stress. This graph is showing a summary of the data that we collected from the photosynthesis study. On the y-axis, you can see 2 of the Wilmington mutants, zoysia grass, San Agustin grass, and Argentine Bahiagrass. The x-axis is showing the soil moisture level from 1 to 0. 1 represents a soil at feed capacity, and 0 represents a dry soil. These points in red, blue, and green represents the point at the soil water level necessary to reduce transpiration, fluorescence, and turf quality to a specific thresholds. The Bahiagrass lines, zoysia grass, and San Agustin grass reducing transpiration at higher soil moisture levels, regulating water use. This is generally good if plants can also maintain photosynthetic activity. And this was what Bahiagrass and zoysia grass did. These grasses regulated water use, maintaining photosynthesis, and maintaining turf quality at lower soil water levels. The top performing genotypes in this study were WEMS 12, WEMS 18, and M98. These grasses regulated water use and maintaining photosynthetic activity later in the drying cycle. M27 and WRX02 perform similarly to Argentine. On this last section, I'm going to present the field trial updates. This plot is located at White Oak Wildlife Conservation. On this location, Argentine, WRX02 and M27 are performing very well and had the fastest establishment rates. WEMS12 has finer leaf texture and darker color than the traditional Bahiagrasses, as well as few seed heads. WEMS12 and 4% EMS have acceptably ground cover, but they are less dense than Argentine, WRX02 and M27. This is another trial located at Royal Poinciana, Naples, Florida. Here you can see how the turf quality improves when the grasses are mowed regularly. This is a close-up of M27 that shows the best stand in this location. And this is M98 that has the best color. This is an interesting finding because these phenotypes have rather a light color in our research plots. This is a 1,500 square feet plot of WMX12. That's the grass with a darker green color and no seed heads. That is being grown in Bethel Farms, Arcadia, Florida. This plot will be harvested and converted to sprigs to plant half an acre and expand the trials. Additionally, 10 lines are being established at Tater Farms, and when these plots grow in, the intent is to harvest the sod to compare the sod tensile strength of the lines. I would like to thank Matt, Tyler, Bethel Farms, and Tater Farms, the Evergreen Golf Course Superintendent Association, the Golf Course Horn Memorial Scholarship, the West Florida Research and Education Center, and the UF turfgrass team for their support and collaboration. Thank you for your attention. I hope you enjoyed the presentation. And here is my contact information in case you need it.